which is the statistics and probability for AI. So we all know that, when somebody wants to do a master's in AI or a specialization in AI, the best first thing is, which is when it comes to aptitude, is you should have good aptitude for mathematics. It's because that we all know that computer, when we say that any machine is AI powered machine, there are three things that we are looking at: computer vision, ability of machines to see like human beings, then natural language processing, which means ability of machines to understand human languages, and the third one is data. When I say data, it means like we humans take decisions basis our experiences. So the experiences of given are given to computer in the form of data. So if I have to say that any specific machine is a AI powered machine or not, I would check whether it qualifies the criteria of three parameters. First, ability to see just like human beings and understand and perceive, be it images, be it graphics or video, and understand it like a human being. So that's computer vision. Like if you take your phone camera and point it to a plant and ask it to give more details about it, so it means when the Google performs Google search and it matches the images with your plant, it means it is able to understand images. Same way when you use a scanner. So for example, if I scan the answer keys of an online exam, OMR sheet or other exams through a scanner, and it then reads those OMR signs and is able to evaluate or do correction on its own, then that kind of software is a AI powered software, because it is able to understand those special marks, and also it uses the concept of computer vision there. Similarly, when your face opens with, when your laptop opens with your face, all of that is computer vision. Secondly is your compute NLP, which is ability of a machine to understand, analyze, and execute human languages. So if I'm giving a command in regional language, let's say Hindi to Alexa, and it is executing, or in a regional language to a software and it is executing. So that's the power of a machine to understand natural languages. And now in all of this, and then third point I told you about data. So like human take decisions based on wisdom, knowledge and experiences, machines take decision basis the patterns that it study from data. So I use the word patterns, I use the words analysis, I used that it gathers some insights, it studies the progression, it studies what is the probability. So all of these are mathematical concept, and hence is the name of our chapter 6, statistics and probability for AI, which is, I will just share my screen and we will go deep into the chapter. So chapter 6 talks about how different concepts of mathematics are used for AI. Now, what is the maths behind any of the AI that we use? So book, like last time I had told you that these books have very interesting starting context which is being given. So for example, if you see it here, it says statistics and probability for AI. What's the maths behind Chandrayaan? So it says that after Chandrayaan 3's incredible success, after landing Vikram lander, and deploying the Pragyan over the rover over the moon, the complex mission involved not only launching a rocket, but also precisely landing the lander on moon surface. Now, how those calculations were done that this lander automatically lands to a specific location on moon. We all know that the moon surface is so challenging. So where to land, what exactly should be the distance when it starts to slow down the speed, what direction it should take. So all of this involves mathematics, and nowadays we know that these kind of systems are controlled by AI. Now I would like to hello Aruna ji, hello Asha ji, thank you for your evening wishes. So I was just waiting for a few more people, but I think let's start the concept. They will join in as and when. So there are two types of terminology that is being used. One is here, first term is automatic machines, and another one is autonomous machines. So when we had started with the concept of AI back in early 2000, so the idea was we saw many movies, and there was one TV serial also where there was a robot who would do house cleaning. So it's not that AI is something new. It's just that it is evolving like anything nowadays, and that's why everybody's talking about it. And it has started to automatically pick up many of the human tasks which we did not even expect that it will evolve so much with the data that we are feeding it. So there is something called automatic machine, and there is something called autonomous machine. So what is the difference between automatic and autonomous? Automatic machines are the machines which automate certain processes, but they are rule-based AI. So we in first chapter we had studied there is one rule-based AI which follows a certain rule. So for example, if you have a fully automatic washing machine, if you put timer for 15 minutes and set it as delicate or synthetic, so the machine would do exactly what you have specified. But imagine if you're washing your bridal lehenga or a very expensive dress in the machine, and you forgot to put in delicate, and you have set the cycle as normal wash, and then you have turned on the machine, will your machine point out after sensing the cloth that, excuse me, it's a delicate cloth but you have put in it into regular wash? That never happens, because our machines are automatic machines. They are not autonomous machines. They are not capable of taking independent decisions. So they use something called rule-based automation process. They have an if-else chip which is being coded that if this is set, then itna temperature lena hai, itna pani lena hai, itni speed se spin wheel ko घुमाना hai, and that's why they are called automatic machines. On the other hand, so I'm writing the example as automatic machines, and then I'm writing the examples of microwave also. So if in microwave there are some ready to eat, there are some buttons, ki idli banana hai, to just press this. If you have to bake a cake, press this. If you have to steam something, press this button. Now imagine I want to make idli, but by mistake I've pressed the button as for cake. So my microwave will not, take its own decision that, excuse me, you have not put in the right utensils, you have not put in the right, ingredients. If you want to make cake, you have put in material for idli, but that doesn't happen. Whatever we set, it performs according to that. Now, when it comes to autonomous machines, the machines which are able to take decisions. So machines that are able to take decisions. Now, how do these machines take decisions? So my whole point of bringing you here was, how do these machines take decision? For example, the biggest examples here is flight simulation system. Flight simulation system is not a automatic process. It's autonomous process. Why? Because when a pilot is being trained on a flight simulation system, the pilot is supposed to take real life decisions. What if a cloud comes in between? What would you do? And basis your action, it automates the another direction in which it has to go. War response system, weather forecast system, these are all autonomous machines, or I would say autonomous processes. So unka software bhi and whatever technology is being used, so these are autonomous, I would say, machines or processes. So here now, how something become autonomous from automatic to autonomous? The key factor here is ability to take decisions. The machines that are capable of that can take decisions, or that are capable of taking decisions. So how do they take decisions? Here the power comes with data. So there is a lot of data that is being fed inside. So an autonomous machine knows that, if there is so much data which is already being fed into a flight simulation system, that if there is a cloud that comes in between, if there is heavy rain, if any one of the engine has failed, what is to be done? So a lot of data has been fed into to deal with real life situations, and basis that the flight system takes decision. So for example, the pilot has put in some speed, and now pilot has gone to sleep, but suddenly there is weather change. So maybe by mistakes, pilot has put in the wrong kind of system in place. Then the autonomous machine is able to take decision, trigger alarms, and raise concerns, because it has that ability to take decision. And what makes it to do that? The data. So data gives the power to the system to study patterns and predict the probable outcome. Next course of action or outcome. So when I'm saying that, when I'm using the word outcome, when I'm using the word prediction means, and probable means, I'm asking it to deduct what is the probability of the next action to be successful. So that is where all the mathematics comes in. Now let's come back to the chapter. It says that let's explore what happens when this kind of projects are being taken. So what decide the successful rate, how the decision is being taken, which place to land, how much speed, how much distance. So all of this has mathematics. Now they have given some example. Where do we use maths in real life? So in mathematics is in real life very much in existence in our natural cycle of orbital movement of planets. So you see they follow an equal distance. There is a movement in clockwise, anti-clockwise, natural cycle of seasons, a pattern that constellations follow. Then we have patterns in various fruits, vegetables, and in nature. So when you have this honey web or spider web, or you have natural vegetables like onion, all of these have in the skin of onion. So there are patterns in nature. So similarly, when we study these patterns, the studying of these pattern and understanding underlying principle is all about mathematics. So it says mathematics is the study of patterns, relations, and logical reasoning. And that's what is very powerful concept of AI, because AI is able to take decisions like human beings basis the pattern, the ability to identify relationship between two objects, find out logical reasoning, what is happening, why it is happening, when was it happened last, what was action taken then, and can that action be repeated in this situation. So all of this is mathematics. So it says it is showing the example of patterns in real life, and then the book takes you to the automated game. So when you play rock paper scissors manually, or you play rock paper scissors with a machine, what happens? There's a lot of probability. So you try to read the mind of other person when you are playing rock paper scissors, that if I have done this topic was not done on Wednesday. No, ma'am, we did this. First day we did generative AI, second day we did Python, and I picked up this topic last. So yes, I did give some context about computer vision and NLP on the first day. But this chapter is little different, and we will be seeing the demo of some more new tools where you would see mathematics in action in AI powered tools. So have a look at this. It says that when you play a game like this, rock, paper, scissors, so what is happening in the back end, AI tries to, it remember the AI game. So what happens, it uses the same principle of pattern recognition, but with a technology twist. So like our brain uses neural network, AI uses artificial network to predict what could be the next move. And you see here, it is using the formulas it is using linear algebra, it is using calculus, it is using statistics, it is using probability. So all of this is being used to find out the pattern in the given imagery. So it's very difficult for a machine to identify the next course of action without including mathematical concept into consideration. It says these artificial neural networks are like mathematical version of neurons called brain cells working together to recognize patterns and make decision, and they majorly depends on these four concepts. Now they have also given this is piece of information, a fact that you can share with your students, that this gentleman, Mr. Hinton, was referred to as godfather of AI for his significant contribution in the field of AI, and he also won Nobel Prize in physics. Then they have now drawn in a parallel between a human network human brain network and neural network, which we also did some bit of it in the previous chapter. It says that these mathematical concepts are used in self-driving cars, chatbots, weather forecasting, to study trends, solve problems, make decisions. So AI completely depends on mathematics. Now, before I move ahead and show you some example, let me just show you a software, and we will play a game with it, and then we will try to draw an analogy how this software must have been using mathematics. So let me just write the name of the software is Akinator. So this is in case you have used it earlier, you can just confirm me in the chat window. Then I will not spend much time. Else, I will show you one demo and then we will jump on to why and how this particular software uses mathematics while making out predictions like an AI. So this is Akinator. This is a game which is available on mobile app. You can download it on App Store or Android Store, and you can play it online also. And it is a guess game. It can guess a character, object, or an animal. And you have to think about like what do you want it to judge. When I say character, for example, if I think in my mind about Shah Rukh Khan, and then it will ask me some questions, and I have Shah Rukh Khan in my mind, and remember keeping Shah Rukh Khan fixed in my mind, I am answering all those questions. Then after a certain number of questions, it will be able to guess what I am asking. So either its guess will be correct or incorrect. While I have played it about 100 times, about 95 times it gives the correct answer. So let's me try it with you. So let's say I take an animal instead of a real person. So let's say I've thought in my mind about, let's say a cow. It says, has your animal got 4 legs? So I say yes. So I have thought about a cow, but so is cow a pet animal? So cow is a farm animal. I'm not sure whether it can be a pet animal or not. Some people keep it, but I think I will say mm, probably. Let's say because it's a farm animal. Is your animal bigger than a dog? Yes. Does your animal eat other animals? So I say no because it's a. Is your animal raised in a farm? I say yes. Does your animal have a cow head? So see, it's already guessed. Is your animal a parasite? Don't know. Is your animal a protected species? Yes, it's a protected species. Is your animal native to? I'll say no, don't know. Associated with herbs? Yes, probably. Does your animal have to do with horseback riding? No. Native to India? It's one few breeds, yes. So see, I had guessed about a cow and it has given a calf, so which is roughly means the correct answer. Now, where is the maths here? So when I asked my students that, let's make this software. So I asked them to analyze how the software must be working in the back end. So if suppose you were to make a game, so I asked them that in chemistry, you are doing periodic table. So why don't you people make an Akinator for guessing the elements in metals and not metals? So you ask 10 questions and 20 questions to the person who is using it. Here the maximum number of questions is 20. In 20 questions is just guesses. Maybe at times in less, at times in exactly 20. So for example, here I have name of animal, right? So I have name of animal. Then whatever questions have come to me, so there is a fixed question bank here. So for example, if I ask here pet animal, herbivorous, then let's say I have whatever, let's say some questions are related to each other, canine, and then big, and then we have, let's say, tail, yes or no, big tail, small tail, whatever. So I'm just taking 5 fields, but there will be in the database of Akinator about 20 fields on top. Then let's say I have cat, dog, pig, let's say lion, tiger. So I'm just putting 5, 6 to just to show you. Pet animal, yes, yes, no, no, no. Herbivorous, no, 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 no. So I'm just putting the answers no, majorly no, no, yes, yes. Dog, some breeds can be tall, yes, and big and tall. Tail, yes, 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 something like this. Now, imagine in the database, there are questions like this. Now, what happens when you ask your first question? The first question was, is the animal uh, a pet animal or not? So what we are doing here is we are putting a filter on this data in the backend. So when first question was, is the animal a pet animal? And I gave the answer as, let's say yes. Here it could be probably yes because there were 4 options. So suppose I say yes. Now the moment I said yes, some options are eliminated. Now I go to my second question. My second question was, let's say, is the animal herbivorous? And I say maybe no. So I'm here. So what happens every time? Every time you ask a question, so suppose in the first round you had 100 records. There were about 20 animals which were pet animals and about 80 animals which were not pet animals. So in a database of 100 animal, when you ask first question, is your animal a pet animal? And you said yes. So 80 are gone. Now the computer has to search from 20. You ask your second question, is the animal a herbivorous? Out of the 20 pets that you had in the database, let's say only 5 are herbivorous. So next step, your search area reduces from 100 to 20 to 5. Now that's how in few questions it reaches to one entry, and that is what the answer it gives. I hope I could make it clear that imagine in Excel there is a huge database and every question is like a category, and when you answer one category, the database in the backend is getting shrinked. And after 10, 12 questions, there will be just 1 or 2 entries left, and the software will pick up one most suitable from there and give you the answer. So I asked my students that here there is a maths in the backend. What is happening in Excel? You are doing filtering, but this is like decision tree is working in the backend. So decision tree is another important algorithm that computer teaches students, that after every step some size of databases shrinked and we are working on a specific zone, and if this is yes, go in this direction, if this is no, go in this direction. So there is probability, there is statistics, there is decision making that is happening. So there's a lot of maths that is being used here. So this was one game which I showed you that how it is done in real time. So and what kind of maths or data filtering it could use in the backend. Same way, so there is probability also, there is statistics also, and there is the data set also on which it is working. Now let's come back to the example. I hope I could make this point clear. So now let's think of another example. So I was showing you one more example the other day. Okay, now let's there is something called things never exist. Sorry. So I'll come to that example in a minute. First, let me relate the Akinator point here. So it says maths for AI is very important because it is used to find patterns, make guesses, and solve problems. And then they have given some more examples. So weather predictions, all AI forecast weather by estimating the chances of rain, snow, sunshine based on the past patterns, calculating like likelihood is nothing but probability. Voice assistant like Siri, Alexa use a lot of voice data to understand and answer your questions. They organize and study this data. This is what we call statistics. Then you have recommendation systems. So Netflix, YouTube suggest content based on preferences. This is done with the help of linear algebra. Self-driving cars use calculus to take real-time decision in terms of position, in terms of changing speed. So that's all calculus. So while linear algebra and calculus play a crucial role in AI technologies and make them more technical and less apparent in use, everyday use, in this chapter, we will focus more on how AI functions specifically in terms of statistics and probability. So what they are trying to say, however, linear algebra and calculus also have a big role when it comes to mathematics and AI. But considering the scope of chapter, we are discussing only probability and statistics. Now, when it comes to statistics, it says every day many decisions are data based. Without us realizing it, consider the situation. So, how does Amazon decide which product to demand? How do business decide which ice cream flavor is most popular? So all of this is basis your stat, like आपकी order history track होती है, आप क्या सबसे ज्यादा order करते हैं और आपकी कौन सी मोस्ट प्रिफर्ड ऑर्डर्स हैं, कौन से ऑर्डर रिवाइज्ड हैं. सो बेसिस ऑल दोज प्रिडिक्शंस द Amazon app or ice cream ordering app or Instamart, Swiggy, all of that give you recommendation basis your पास्ट हिस्ट्री. आपके पास्ट हिस्ट्री में से पैटर्न्स निकाल के प्रोबेबिलिटी के अकॉर्डिंग. फॉर एग्जांपल एक Amazon का एक वीडियो है which I'll just show you also if I find it on Google. It says that there is something called anticipatory shipping. हम अभी शॉपिंग करते भी नहीं है मंथली. जो लोग मंथली Amazon से ऑर्डर करते हैं, तो Amazon क्या करता है, वो प्रिडिक्ट करता है कि इतने लोग हर महीने बेसन मंगाएंगे, इतने लोग हर महीने आटा मंगाएंगे. सो आपकी कार्ट में भी वो रिकमेंडेशन आने लगती है जब आपको 20 डेज हो गए होते हैं आटा ऑर्डर किए या जो आपने पास्ट में ऑर्डर किया है. और इनका भी एक कॉन्सेप्ट है एंटिसिपेटरी शिपिंग, मींस दे गेस कि लोग क्या ऑर्डर करेंगे और उसके बेसिस पे वो अपना स्टॉक पहले ही फुल कर लेते हैं. सो बिफोर वी ऑर्डर, इट ऑर्डर्स टू इट्स वेंडर्स बेसिस द एंटिसिपेटरी शिपिंग डेटा. सो एंटिसिपेटरी शिपिंग डेटा कहाँ से आता है Amazon के पास? दे हैव अ स्ट्रॉन्ग AI इंजन जो हमारी शॉपिंग पैटर्न्स के बेसिस पे एंटिसिपेट करता है कि आगे लोग क्या ऑर्डर करेंगे. So we will just see this video. This is though not the one which I wanted to show, but let's see what it comes. I hope you can hear the voice. Let me just check.
How does Amazon's anticipatory shipping work?
Are you able to hear the voice? Let me just share it again because I'm not sure whether you are able to hear the voice or not. I did not share the screen, seems with sound. I will share it again. Okay, so I'll just play it. Now let's watch it.
Shopping online and getting your package faster than you expected. It might sound like magic, but it's actually smart technology at work. Amazon uses a special system called anticipatory shipping to make this happen. This system relies on predictive analytics, which means analyzing a lot of data to guess what you might buy next. It looks at your past purchases, what you browse, your location, and even regional shopping trends. Using artificial intelligence, Amazon's system estimates which products you are likely to order soon. If the system predicts you might want a new pair of running shoes or a popular gadget, Amazon prepositions those items in warehouses or local delivery hubs close to you. This way, when you place an order, the product is already nearby, cutting down the time it takes to reach you. The process starts with collecting huge amounts of data from millions of customers. This includes what people buy, what they look at online, and regional shopping habits. Then, advanced algorithms analyze this data to forecast future demand. These predictions are constantly refined as new data comes in, making the system smarter over time. Amazon then moves inventory proactively. Sometimes, products are even placed on delivery trucks or in local distribution centers before anyone orders them. This means your package can be shipped from a nearby location, not from a distant warehouse. This reduces shipping time, often turning a several-day process into just 1 or 2 days. This approach benefits Amazon by lowering shipping costs and improving customer satisfaction. Faster delivery means happier customers who are more likely to shop again. It also helps Amazon stand out from competitors by offering quicker service. If the system predicts that a product might not sell well in a certain area, Amazon can offer discounts or special promotions to encourage purchases. From a data analysis perspective, anticipatory shipping is a perfect example of how combining customer behavior data with supply chain management creates a more efficient system. It uses machine learning to improve predictions constantly, making inventory placement smarter and more responsive. Of course, there is some risk involved. If the prediction is wrong and the product doesn't sell, Amazon might have to deal with excess inventory. To avoid this, they often use discounts or send promotional gifts to customers nearby, turning potential waste into an opportunity to boost sales. In short, Amazon's anticipatory shipping works by predicting what customers will want before they even order it. It then moves inventory closer to those customers, making delivery faster and more efficient. This smart use of data and predictive analytics helps Amazon stay ahead in the competitive world of online shopping.
I hope you got the concept. And there is a lot of maths that goes into in terms of statistics and probability. So coming back to the chapter, that's why it gave the example that how does Amazon decide which product to recommend and which product to order? How do social media platforms suggest trending videos? Same thing, your data, your patterns, your history, your surfing style, everything is being taken into, and basis those data, patterns are identified to recover meaningful insights. Recently, there is one of my student was working with a company which wanted first to make memes, as a platform. They made a platform for memes. Like we go to Instagram for reels and all. They said our software will be a specific platform for memes. So later on, they say that, why can't we make it a friendship portal? And where people get friend suggestion basis the memes that they like. So if we are watching memes and your and mine, so when people log into their app, they would ask them to choose 10 subjects on which they would like to see the memes. Let's say I select subject as education, entertainment, and maybe technology. So I suggested my field. So you select your field. So there will be people, those who will have common flavor. So like we all are teachers. So everybody who goes to that app will have education as a common connect. So now whatever memes you are saying, I am also seeing those. Now, if we tend to like the same memes, it means our taste matches. So if, the software had this algorithm, my student told me that if people like 5 memes, if you are liking 5 memes and I'm also liking those 5 memes, so software will suggest me to send a friend request to you that we have same taste and we will gel well. So it was first a meme platform, then it became a platform where, like Facebook, people send friend requests to each other and become friends. And today that's one of the unicorn, and it is a Stanford University startup, and its name is Shumos, and it now has become a dating app. So if people like same kind of memes and content, then the app proposes them to be soulmates, and it became a dating app. So that is how, technology is paving way into every sector. And maths, there is everywhere, there is mathematics, especially statistics and probability. So there are more examples which are given in this chapter, and it's talking about, if you deploy, this is a very simple example which is not even related to technology. It says watch this full video and then using this statistics diagram, find the number of cars spotted. So this you can ask the children to do this exercise. But what I was trying to say that, so when cameras are being put up, for let's say uh, people want to study that on this particular highway, which of the cars have never met with an accident, what are the common heavy vehicles that go, and they put in a particular camera. So the data सेंस्ड बाय द कैमरा, जो कैमरा में जो पूरा रील है, जो वीडियो है, वहां पर वट एवर एक वीक का डेटा उन्होंने स्टडी किया, 2 वीक्स का डेटा उन्होंने स्टडी किया, देन द आर्टिफिशियल इंटेलिजेंस बेसिस द color prediction, basis the model prediction, can spot how many cars passed by during that area, how many of them were heavy vehicles, how many of them were not so heavy vehicles, but ordinary four-wheelers and small vehicles, big vehicles. And then they can give the predictions that these kind of vehicles are good for highway and they never met with an accident. So that is also many use cases in real life. Now the chapter talks about the example of statistics also. So it says statistics, there are 5 major concepts that we study in mathematics: mean, median, mode, standard deviation, and then in higher classes we also see focus on graphs and charts, and we understand how they are being used to present data and identify data. Now they are giving some case studies here. It says first case study is about Tokyo 2020 Olympics, which was one of the biggest sporting event in the history of the world, bringing together athletes and everybody from different countries. However, with COVID-19 still spreading, hosting such a large event posed a major challenge. Officials needed to ensure the safety of participants and the public. The key question was, would it be safe to hold Olympics as planned or should it be postponed? So solution is to make the right decision. Officials relied on statistics and data analysis to predict how the situation would unfold. They examined historical COVID-19 case trends in Japan, provided population movement in Tokyo, and vaccination rates. Predictive graphs showed that the cases had been fluctuating but were expected to increase sharply during the Olympic period. Officials assessed whether current health measures could manage the expected rise in cases. After analyzing the data, they concluded that postponing the event was the safest option. So that is where the data was analyzed and mathematics was used. So its impact is postponing the Olympics helped avoid a possible health crisis and allowed time for better safety planning. When the event finally took place, strong measures were in place to ensure safety of athletics, officials, and spectators. This case study highlights how statistics help in making informed decision for global events. Now, case study 2 is Google flood forecast. So says floods are a common and dangerous natural disaster in monsoon prone area. So Bihar or Assam में जब भी floods आती है, there is a lot of damage to lives and property, and this is because of the warnings doesn't reach to the affected areas timely, and people are unprepared, and which leaves them in a devastating situation. So it was analyzed that if they could get the information well in advance, then maybe they can be evacuated from those places. So in 2020, Google partnered with Indian Central Water Commission to develop a flood forecasting system powered by AI and statistics. And this system used data like historical rainfall records, river flow levels, real-time weather update from satellites and underground and ground sensors. With this data, AI identified patterns and created models to predict when and where the floods were likely to happen. The forecasts were then shared with people through smartphone notification, often giving them several days of advance warning. So the flood forecasting system proved to be life-saving for vulnerable areas like Bihar and Assam. Millions of people received early warnings, giving them time to prepare and evacuate safely. This reduced the loss of life. So these are real-life applications of statistics in AI. It is used in traffic management. It is used in attendance, exam result, helping teachers to improve student progress in education, sports analytics, e-commerce, agriculture. So there are couple of fields where in real life it is being used. After the Titanic sank, the mathematician analyzed survival data and found that women and children had a much larger survival rate than men. First class passengers had a high probability of survival than those in third class. People closer to lifeboat deck location had significantly better odds of surviving. So these kind of predictions could be made after analyzing the data. Although it was discussed above that statistics has many uses, it doesn't work alone. It can predict future events only when combined with another powerful mathematical concept called probability. Now, imagine, for example, let me just show you something. For example, you have, I'll go to forms and we keep doing various feedback with people with on after every occasion we take feedback. So I'll pull out one feedback and show you how data is analyzed by AI and how it generates quick summary and how it uses mathematics. I'm showing you through Microsoft Forms. You could even use Google Form also to. Okay, let me see. I think I downloaded also. Let it open. Okay, so here is the form that I'm talking about. Now see this pattern. So people are filling in a Microsoft form for feedback. So what we did, we after our event, we made a feedback form which was circulated by to the parents. Now there are 55 responses. Now when I open this form, so it shows me a statistical view of the data. So the AI engine used here is analyzing my data in real time. Why it is analyzing in real time? Because when abhi today there are 55 responses. Now suppose tomorrow there are 100 responses. So when I go to view responses, my this response time 55 responses, average time is 20, the average time was given, then days are given, how many days have been happened. This is past 7 days, it is analyzing the data. 51 excellent, 4 very good. So when people are filling in, this depiction is automatically getting updated. So when it says mention a few things, it is showing me the summary of the responses. This image word cloud is also automatically made by the AI engine. And then if you come to the last part of it here, so how many parents from which class has given response, so these graphs will be updated in real time. So this you can even print this summary here. This is first part of it. Now if I take this particular document and download it, and then I go to chat gpt, or I showed you yesterday you classify. Let me try chat gpt now, and let's see how AI can help me further. So for example, I've got this feedback, and in this file, there was a field suggest measures how we can improve future events. So any two suggestions we were asking to the parents. Now imagine if I upload this particular file here. So suppose I upload this feedback of parents here. Okay. Hmm. Let me show you through Gemini. I exhausted my daily upload limit. That's why it was not allowing me. I'll use Gemini to do this. Sorry, I think the call was dropped. I'll just reshare my screen and explain what I was trying to do. So in Microsoft Excel also nowadays you have something called ideas, and that can help you to analyze the data, or otherwise you could upload your Excel to any AI engine, be it Gemini or Copilot or ChatGPT, and ask it to analyze the data and give you the crux of it. For example, in my case, we had just 55 records. So still somebody could manually see and understand that what suggestion parents are giving, and what are two major areas or good suggestion that one could look into. But if you have huge responses, let's say 2000, 3000, and you do not want to waste time doing data analysis yourself, AI engine can be very powerful. So I'll show you, I'm just sharing my screen. So I'll show you how you can be, supported with the help of an AI engine. And you can just upload your file, and the entire analysis in terms of statistics and probability can be done by the AI tool that you are using. Okay, let me just share my screen and show you. So here, okay, so I've uploaded the file here, and I'm asking Gemini, study this spreadsheet, give me 3 relevant suggestions to keep in mind to improve the keep in mind to for future events. For example, I'm writing for future events, because there was a question that we asked, that how can we improvise these events in future. Now AI is studying that for me. It says, of course, based on data, prioritize and expand your email, use paid events to increase attendees' commitment. Okay, just 1 minute. This is thinking. No, this is not, this is reading my spreadsheet, and what it is thinking that is being coming here. Now, if I want very specific output, one way is I could read AI prediction. Now, let me show you how even in Microsoft Excel, without going to a third-party tool, if you are in Excel itself, so this is, I'm in Microsoft Excel only. Here I have this option called Analyze Data. If I click here, even this as an AI engine, and it can help me. It says, could you count of overall how many, from each class responded excellent, and how many from each class responded very good. So this is showing me class-wise data. If I click, it says excellent accounts for majority of overall. Then how would you suggest to improve this in future? So maximum suggestions came from 4th A. Now, if you want to add any more questions, So it is suggesting questions also. Percentage distribution, if you are asking that from each class, how many people have, answered. So you can even, AI engine can also suggest you on what questions you can generate report from. These are the probable questions it is asking. We can see it from here. So analyze data is also an AI powered tool to looks for patterns. So it says इसकी definition में देखिए आप यहाँ लिखा है, it looks for patterns and then it helps you generate the probable outcomes. So let's go back to the example which was given in our textbook here. It was talking about the probability in everyday life. It says, will the sun, we might have encountered these questions. Will the sun rise in the east? It's monsoon season. Will it rain today? Will India win the toss? I bought a lottery ticket. Will I win the lottery? Will water go uphill naturally? All these answers, questions have different answers and they are always not the same. The sun will rise in the east while water will never flow uphill naturally. Rain in monsoon season is likely and winning a lottery is very unlikely, but still possible. Some events will definitely happen, some might happen, and some can never happen. Such happenings are called events, and the chance of these events occurring is called probability. Probability is the number that tell us how likely an event is going to happen. So nice explanation is being given here, and we can explain it to our students. It tells about what are the chances of something occurring ranging from 0 to 1. The highest probability being 1, that is the event is likely to happen. And this is the formula that is being used. For example, in case of head and tail, the number of favorable outcome is 1 and the total number of outcomes are 2. And the probability is 1 by 2. Same way, in different kind of events, we can use the concept of probability. Like in the case of when you throw a dice, what number comes, the probability of numbers is being explained. Same way, there is equal probability events. So when you are playing a game of dice, what are the chances of getting a particular number? So they've explained the process, how unlikely events less than 50% probability, the only number less than 2 is 1. So for example, if the question is what is the probability that the outcome on the dice will be less than 3? So in those cases, your total number of outcomes get reduced. So those kind of possible combinations are being shown and explained. Then there is another example. It says a pig flying in the sky, a person living without breathing. In some way, probability 0, a triangle having 4 sides. So these are the incidences where probability is 0%. Now, there is this exercise which you can ask your students to do when you do this chapter. There is a bag full of marble where 6 marbles are blue, 3 marbles are yellow. Fill in the blanks that what is likely, unlikely, certainly impossible और इक्वल प्रोबेबिलिटी. अब इन्होंने ऊपर आपको एग्जाम्पल दिया है. लाइकली का एग्जाम्पल क्या है, अनलाइकली का क्या है. सो इक्वल प्रोबेबिलिटी मीन्स 50% चांसेस है. दैट इज when probability is greater than 50, likely event. When probability is 100%, certain events. Then when probability is unlikely, less than 50%. When it is impossible, 0%. Now, keeping then this mind, we have to answer this. If you pick up a marble from a bag without looking, dash, it is dash that you will pick up blue marble. A bag is full of marble where 6 marbles are blue, 3 are yellow. So 6 marble blue है, तो blue की probability 50% से ज्यादा है. So this is, it's asking what is the probability. It is likely that you will pick up a blue marble. If you pick up a marble from the bag without looking, it is less likely that you will pick up a yellow marble. There is 0 probability that you will pick up a red marble because red तो है ही नहीं. If you remove 3 blue, तो दोनों बराबर हो गए, blue और yellow. So it is 50% probability that you will pick up either blue or yellow. If you pick up a bag from an object without looking, you will 100% pick up marble because marble के अलावा उसमें कुछ नहीं है. Now they say that these in real life probability applies to detecting of spam mails. So when mails land up in spam, people, report spam. So basis the reporting of that kind of mail as spam, the spam detection system make probability that what is the probability that it is a spam mail. How many people have reported such kind of mails in past as spam mails? So, and if the mail has some, fraudulent links like or mail have extensions which are not so common, so then those are the added signs of guessing that it is a spam mail. Millions of mails are sent daily, but many are spam containing false links, scams, or misleading offers. If these mails reach users, they pose security threat and create inconvenience. However, not all mails are spam. So Google uses, how does Google predict it? Solution is Google spam detection system use probability to decide whether an email is spam or not. It analyzes millions of past email to identify pattern. If it has such words, such links, such attachments, then it decides that it should also be dumped into spam. Otherwise, it moves it to inbox. So then it is shown one more example. In this solution only, how they have tried to guess. It says if an email exactly like previously reported fake mail means 100% matching, then it is spam. Greater than 50, again it will be spam. Equal probability हो सकती है अगर spam है या normal mail है. So email has both safe and spam like characteristics, then 50-50. Unlikely event, if a mail doesn't strongly match spam patterns and has minor red flag, then it can go to inbox. Impossible event, if an email is from a verified source, frequently contacted sender, then the probability of being spam is never marked as a spam. Impact, by using probability, Google blocks over 99% of spam mails, so you don't have to worry about it. 99% job of identifying spam mail is done by Google itself, and they are being dumped into junk or spam folder. Same way, then next case study is about self-driving cars. Okay, I'll just show you a video. This is very interesting video. I hope I find the right one. So we are asking probability in self-driving cars. I think there is this, this was by Tesla only.
Hey everyone! Today we're diving into the fascinating world of self-driving cars and the math that makes them tick. Now I know what you're thinking. Self-driving cars are all about sensors and cameras, right? Well, yes, but the real magic happens with advanced mathematics. Let's break it down. First off, why should we care? Imagine a world with fewer accidents, optimized traffic, and a revolutionized transportation system. That's the promise of autonomous cars. But how do they make those split-second decisions? The secret sauce is math. Now, to get into the nitty-gritty, let's talk about the key mathematical areas. Linear algebra for sensor data and transformations, calculus for predicting motion and control systems, and probability for handling uncertainties in perception and decision-making. Sounds complex? Let's simplify it. Starting with sensor fusion and probability. Picture this. A car is processing input from LiDAR, radar, and cameras. Using Bayesian inference, it updates the probability of an obstacle being in its path. So, if radar detects an object with 80% confidence and LiDAR with 90%, probability theory helps combine these inputs for a more accurate picture. Next up, path planning with graph theory. Imagine your car choosing the best route using the A** search algorithm. It's like a dynamic map where nodes and edges light up to find the safest and shortest path. This cuts down travel time and keeps you safe. Then there's motion prediction and differential equations. Think of a car predicting a pedestrian's movement. Using calculus, it models acceleration, velocity, and even jerk, allowing the car to anticipate and react in real time. And let's not forget control systems with PID controllers. Ever wondered how a self-driving car adjusts its steering and speed so smoothly? PID controllers use calculus to minimize the error between the car's desired and actual positions, ensuring those perfect turns. Now, on to neural networks for object recognition. Deep learning is a game changer here. With convolutional neural networks, the car can detect objects like stop signs or pedestrians in real time, even under poor lighting conditions. Amazing, right? But it's not all smooth sailing. Current research is tackling challenges like adversarial AI attacks, where minor modifications to road signs can trick the car's AI. Engineers are working hard to make self-driving cars more robust against these threats. Alright, I've got a couple of challenges for you. Can you implement the A** algorithm for a simple grid-based navigation problem? Or, how would you adjust PID parameters to prevent overshooting curves? Give it a shot and see how math truly drives autonomy. To wrap it up, the future of transportation is heavily dependent on mathematics. From probability to calculus, every aspect of self-driving cars is a mathematical challenge waiting to be solved. Thanks for watching, and don't forget to like, subscribe.
So here, this is a beautiful video. While I show such videos to my students for self-driving cars and mathematics, I give them also this case study where I bring in the biases aspect also. So for example, if a person, if there is a self-driving car which is on road, and now there are two dead ends. One side, the car would hit the, a particular wall or something. On the other side, there are some school-going children, those who are coming. On the third side, there are very old age couple who are walking. Now, car has to go in one direction. Either it has to hit and get crashed, or it has to hit the children, or it has to hit the old people. Now it's a self-driving car. It has to take autonomous decision. How car is going to take a decision? Now, first thing is, if the person, those who are sitting, so these are all probabilities, and these cars are being fed with data, and all such situations are fed into the data. Now the person who is filling the data into this system says, that when you come to such a situation, first save yourself, forget about everybody. So it means the person has to save himself. Now, if the person has to save himself, the second step is, so it is not going to go in a direction where he's going to bang himself in the wall, or the vehicle has to bang itself in the wall. So then there are two more directions left. One hitting the younger children, second hitting the older people. So then I asked them that, if the person who is feeding in the data in this software feels that the person who is already very old has already lived their life. So those people have, spent about 50, 60 years already, and these kids have a long life to live. So better to save the kids and let us hit the old people. On the contrary, there is another gentleman who is training the self-driving cars in, let's say, America. This is a person in India. And the person in America feels that the newborn babies are just born. They have not seen the world, but the people, on the other hand, have so much of experience, and the global community can be benefited from their experience. So this is absolutely not a problem if younger children pass away, because if they hit the younger children, because they have just born, even the parents can have another child, they can adopt it, so it's not a big deal. They're too young. So the other person have different perspective. Now, if the cars are trained by the people who have different biases or perspective, those biases or perspectives are likely to come in action when these autonomous model work because they are purely dependent on the kind of training data. So this was one example, which I'm sure in real life it doesn't happen like this. Company has policies, they make people to sit together, they take decisions, and then the car is being given these kind of data. But imagine situations, other real life situations where people, those who are filling data, for example, if somebody is being asked to put in the data about different 30 different religion in India, and that person is biased towards one or two religion and is saying all good things about those and not so good things about other religion, and the person who is searching on the internet or using a chat GPT or any other engine to find about religion, the outcome is affected by biases which and went during the data entry time, then it becomes a problem. So biases with AI is a great problem and it has to be dealt. And one part of the chapter towards the end talks about this as well. Now, this is the driving car case study which we were discussing. It says self-driving cars are designed to drive safely without human controlling them, but roads are unpredictable. A pedestrian might suddenly cross, another car might brake unexpectedly, a traffic light might change at the last second. The car must make quick decisions to avoid accident and smooth driving experience. The challenge was, how can a self-driving car predict what will happen on the road and react instantly to make the safest decision? Solution is self-driving cars use probability to analyze real-time data and predict what can happen next. Sensors, cameras, AI track everything around the car, then vehicle, pedestrians, traffic signals, and road conditions, and use probability to decide the best action. So this is, they are also now referring these cars as autonomous cars, and they have to take autonomous decision. Now, what are the certain event means 100%. If the traffic light is red, the car must stop. There is no second thought. So it's a certain event, 100% probability. Event likely, where the probability is greater than 50%. If the pedestrian is standing near a crosswalk, there is a high probability that they will cross. So the car has to slow down. Equal probability, 50% again, if the another vehicle is moving, car near an intersection, there is an external change, it will turn and go straight. So the car stays cautious. So these are different cases that we will be discussing, and all these are being discussed here with the example. Now, impact is by using probability, self-driving cars make fast and safe decision, leading to fewer accidents as the car reacts so quickly to danger. Smoothly driving as the car predicts movements and adjust accordingly. Better traffic flow as AI continuously learn and improve road navigation. Now, there is another case given about guessing who will win the match, or when will the sun rise. So these kind of problems are very simple problem for an AI to guess the answer. But it says that children can take these kind of questionnaires and fill these keywords: likely, equal opportunity, unlikely, or impossible. Now, these are the applications of probability being given. This is traffic estimation, weather forecasting, sport analytics, fraud detection, medical diagnosis, remediation system. So all of this is examples of AI, use of mathematics and AI. So all these have a lot of data or lot of use of percentages, probability, and statistics. Says your phone keyboard predict the next word you might type. This is because AI analyzes millions of patterns and uses probability to suggest that word, likely words based on context. Now, next is we have explored maths in AI. We can see how these concepts help AI analyze data. Okay, let me just show another example if that works. So if you go to this, there is something called Maths Progress. It is a Microsoft app. It is available in Microsoft Teams also. And now with the help of an
shaping
Office
a bold
365
new
ID
language of
or
design,
an Outlook ID, you can
chiseled
use it
to
without
perfection.
Microsoft Teams also. I'll just skip the ad.
Seamless, flawless. Introducing Fluido by Crompton. Sculpted, not made.
I'll be showing math progress in Teams for Education. Math progress is our newest learning accelerator. I'll be showing math educators to generate all sorts of math progress is our newest learning accelerator. And it's great for educators to generate all sorts of practice problems for students to work on. And it's great for the ages of 9 all the way through 18. Math progress is fully rolled out and globally available today, so let's get started. I'm here in Teams for Education and I'm the educator. I'm here in my class and the first thing I'm going to do is switch over to assignments. Down in the lower left, I'll click the Create button. And note there's a new option here, Learning Accelerators. All 4 of them are here. Reading Progress, Search Progress, the new Math Progress, and the new Speaker Progress. You can access them directly from the Create button. Now in this case, I'm going to click on New Assignment and I'm going to show the other spot where you can add Learning Accelerators to an assignment. Right here is the button Learning Accelerators, and I can choose Math Progress. Now before I do that, we'll give this assignment a title and some instructions. And just for fun, we have our AI instructions for assignments. I'll click Add Detail, and it's going to quickly add this in nice details. There we go. We'll choose to keep it, and I'm going to choose to add some sparkle because that adds a little bit of color and fun. Okay, some emojis added, and we will click on Keep It. Now, next we'll click on the Learning Accelerators button, and I'm going to click on Math Progress. This launches Math Progress, and this is for the educator. This is going to let me generate my own set of questions, or I'll be able to create my own or mix and match. First, we'll click down Category. Numbers and operations, fractions, expressions and equations, and algebra. So I might choose expressions and equations, and then choose a topic. Linear equations, quadratic, polynomial factorization. So there's lots of little explorations you can do here, all these different topics. So logs, polynomial, powers and roots. You have a lot of different things you can do. Might be more simple for numbers and operations. Math Progress handles everything from 4th grade all the way through high school and your senior year. Now I'm going to choose expressions and equations, and for the topic, I will choose quadratic equations. Now I'm going to choose generate. This will quickly generate a bunch of questions for me, and I can choose any of these that I want. So maybe I want this one, this one, this one. Now over on the right, it's adding these questions as I click on the option. Maybe I want that one. So I have a bunch of options right here that I've chosen, and you can see right here, it's added them. Maybe I add one right here and it turns out, you know what, I don't want that. If I click the little X there, that will take that one away. So I've quickly added some questions here, and you can experiment with what you want to do. Now maybe I want to create my own as well and add to these. So I have the ones that were generated and I want to create my own. So if I click add a question, I can choose a category. So same thing, I've got all these different options right here. Maybe I want to choose something very simple like numbers and operations, and I'm going to choose multiplication and division. So you have multiple choice, or you can choose short answer. And short answer doesn't allow you to have any multiple choice. They will put in whatever they need. But what's nice is there is a really rich math calculator. So here's the basic, you can see, and then there's formulas. So everything from algebra, trigonometry, statistics, calculus. So a lot of options for your formulas here, even the Greek alphabet. So it's really rich, and you can experiment with this math calculator. And just to note, when you create a question with a math calculator, your students will also be able to use that exact same math calculator in terms of when they're filling out that question. In this case, I'm going to choose multiple choice, and we will have a very simple.
So I'll not play it full. The idea was to show you that there are many AI-powered tools which are available where teachers can create maths assignments, and even the step-by-step solution is also available to the students and to the teachers, those who want to use that. Now it says we have explored math in AI, and we can see how these concepts help AI analyze data, make predictions, and optimize decisions. Now let us now answer the question we started with, that Chandrayaan problem. So it says, how did Chandrayaan 3 achieve extraordinary precision in landing on the moon? That was the burning question. Scientists achieved extraordinary precision in Chandrayaan 3 using the power of mathematics in AI. Just like AI predicts traffic, detects spam, and helps self-driving cars navigate, it also helped the crucial role in guiding the Vikram lander and Pragyan rover safely on the moon. Now it says statistics analyze data from past missions to improve landing accuracy. Probability helped predict the safest landing spot. Linear algebra processed real-time navigation data. Calculus fine-tuned the speed and trajectory for smooth landing. By combining these mathematics tools, AI made real-time decision adjusting the spacecraft's path and ensuring a perfect landing, a feat that seemed impossible but was achieved through the power of math and AI. A strongest understanding of maths and AI leads to career in technology and innovation. Data scientists analyze data using statistics, while AI engineers build machine learning model for self-driving cars and voice assistants. Robotic specialists develop intelligent machines, and AI is transforming finance and healthcare. So the crux of the chapter is that maths is at the core of AI. When we think about identifying pattern, relationships, logical reasoning, it is all about mathematics. Like we have neural networks in our brain, artificial neural network inspired by human brain helps to recognize pattern in data, make prediction, and perform other complex tasks. AI use statistics to analyze data, probability to make prediction, and linear algebra to make complex pattern, and calculus to fine-tune learning. And it is also given those depending on the probability, the events are classified as certain, which means 100%, likely means greater than 50%, unlikely means less than 50%, equal opportunity means 50-50, and impossible means 0%. So mathematics is the foundation of AI to solve all real problems. Data collection requires careful consideration of ethics, and we must avoid biases. This is what I was trying to tell you. Let me give you one more example here, because it becomes very tricky to explain children that computer can also have biases and how those biases can come just by some stupid act of we humans only. Now imagine a placement cell of, let's say, a college asked the placement cell to pull out data that in each year which companies are coming and how many number of students they are taking from the campus. So what the placement cell did, they uploaded their data on the internet of last 10-12 years. So they mentioned in the table like year so and so, so many children, so many boys appeared for interview when Microsoft came in. So let's say they said that Microsoft took in year 2000 50 boys, 3 girls. In 2001 they took 60 boys, 7 girls. In 2002, so they're putting that kind of data on the internet. Now when somebody is asking an AI engine to analyze the data, so AI engine says that Microsoft is biased towards towards boys and is not promoting girls in STEM because they always take more girls. But the problem was the one who uploaded the data did not mention that if Microsoft took 50 boys, how many boys sat in the coding round? Maybe Microsoft took 50 boys out of 400 boys who sat and took 3 girls out of 15 girls who sat. So one has to calculate the percentage. But since the data was half uploaded, the AI model developed certain biases and gave wrong output that Microsoft is not promoting girls in STEM. It is the other way around. They were taking about 70% of the girls, those who were appearing for interviews, those who were reaching the second round of coding, while among the boys, they were taking only 1/7 or 1/8 of those who appeared for the interview. So it was absolutely other way around. But since the data was not projected or fed in the right manner, the model developed biases. So one has to be has to require careful consideration of ethics. We must avoid biases, get proper consent, maintain data transparency, protect anonymity, and be accountable for usage. Data features are characteristics that describe our information, with independent features used for predictions and dependent features used showing the results we want. Data processing stages involve cleaning and organizing raw data by removing errors and standardizing formats, combining sources and eliminating redundant information. Redundant information means which is obsolete, which is not relevant. So during data analysis, we examine data through various methods like sorting, graphing, calculating averages, and identifying patterns to make meaningful data. Now, there is a beautiful website if you want to explain it to the students, that's called TensorFlow. So I'll just go to TensorFlow. This actually tells on the impact of, so this is basically a deep learning model. If you check this website, TensorFlow, you can get started with it. I'll just show you the tutorial. So just see it and then we will.
You've probably heard a lot about AI and machine learning over the last few months, and maybe you've been inspired by videos showing what's possible with AI and machine learning. But what is it really? Once you go beyond the hype and get down to writing code, what does AI really look like? Well, that's what we're going to go through in this video series, where we'll teach you what it's like to write code for machine learning and how it provides different, new, and exciting scenarios that will help you write applications that behave more like a human being, giving you artificial intelligence. I'm Lawrence, and I'm going to be your guide. You don't need to know a lot to get started.
I'll just forget
which
the
one's
forwards a little bit.
This is a really, really different core of machine learning.
Now see,
and the path
it is
with
basically,
a thumb in.
you know, when
If you've
people
ever
play
written-
rock, paper,
But how would you
scissors.
program a computer to
So how computer is being programmed into mathematics, that looking at the, when suppose I'm playing rock, paper, scissors through my computer camera and I have my hand movement like, this, then how computer predicts that what action I'm going to do. So it is showing all those movement and how machine learning model is being trained, what is the probability. It shows all the calculations. So you can also, if you have, since I do not have that much time to show full 10 minutes video, but I'm giving you this link that if you write TensorFlow and you want to show them how mathematics work in machine learning, you can actually explain a lot through it. Okay. Another thing is, if I take you to this platform, I'm just showing you some examples, which, because teaching this without examples can be dry at times, and you want to give your students some good, interesting examples to show maths, physics, and AI, and how probability works. Now, there is an entire combination of, so this is, it's about a piano that responds to you. So if I say play, I will play the first beat. Okay, now you see, if I am playing something, so in my response, AI is also playing the music, and it is being played in such a manner that it's creating a good piece of music. So its name is AI Duet. Duet means we are playing in duet. Now what's happening here? When you click on these buttons, so bases the past data, how people press buttons, and to response of each button pressed by human, which response will go best in combination. Those probable combinations are so if you click here, now see, yellow ones are the beats by system. So what it is doing, it is predicting that what human can play and what it can play best in response. So this is one. Similarly, if I show you a few more examples. Now, there are many free AI generator tools. Even ChatGPT does that for you. So you just have to give a prompt and it generate images. But if you ask, what is the maths behind it? So when you give your condition that generate this kind of image for me, so what it does, it studies the previous pattern. For example, if you are asking to make a person who is selling balloons, so it will pick up a real time picture from the internet where somebody is selling balloons, and then it will identify the placement of colors and imageries in different pixels. Then it will try to remix those pixels and then come up with a probable outcome that is not exactly similar to the real one, but looks like what we are asking for. For example, I am saying generate image of Indian balloon seller. So what it is going to search out, it is going to search out in its database the picture of, first of all, an Indian person who looks like a balloon seller, and then there has to be balloons there. So then it will generate the image. Now, there is a lot of mathematics here in terms of probability, in terms of calculation of pixels, in terms of identification of size. So all of that, those are mathematics concepts. Plus, there is computer vision to identify and understand what kind of image is required from the pool of database of images it already have. Okay, I'll show you another good example of mathematics. Let it first finish this, and then we will see one or two more examples. Now, by the time it is opening, let me just ask you one question. If you teach board batches, have you ever noticed that when the CBSE curriculum is being given, it gives a chapter-wise breakup? Then 8-mark questions from this chapter, 10-mark questions from this chapter, 20 marks question from this chapter. If you have noticed those, and if you know that on the CBS website, the soft copy of NCERT books is available on cbse.academics.in. I see. So we can easily get on internet the soft copy of all the CBSE books. So what I usually do to prepare my question paper basis the CBSE recommendation, what I do is I upload the chapter wise PDF. Suppose I have my UT exam and I have 3 chapters, and I know that as per the CBSE requirement, there has to be this much. So see the image. How would you rate this image basis the prompt what we gave? Indian balloon seller. Do you think it's a good picture? So can you show your reactions in the chat? Are you happy with the outcome? So how much marks out of 10 you will give to ChatGPT for this? Are you all able to see? Okay, someone has responded. Yes. So are you happy with the outcome of what GPT gave with the prompt? Now, I was giving you another example where I was saying that I've used it for question paper generator. So let me just show you here with the help of, I've previously also have done that. For example, I search from my existing searches about the EVS paper which I generated. So as I was telling you that we know for a fact that each chapter has a certain amount of weightage. So what if we, for example, this is question set creation. So I went to this chat. I'm opening my chat history only to save on time. And what I did was, can you please stop annotating on my screen? Okay, so I was trying to tell you that what I did is I uploaded the soft copy of, this is the soft copy of my term 1 paper. Before that, what I did, this is to create the marking scheme. I uploaded the soft copy of the chapters from which I was to make the question paper. And then I gave this instruction. Say, for example, this is changing time. And the weightage of this chapter is, let's say, 5 marks. Then I said, based on this chapter, give me 5 marks MCQ. Give the reason, match the following, true, false. And it gives me questions basis that chapter. Now I'll show you once again. So here also there is a lot of mathematics. If you want to say that since I have to upload, my daily limit is over. So I'm just giving you the instruction that if I upload my chapter PDF and I say that based on the 4 chapters attached, so this is the kind of prompt one could give based on the 4 chapters attached. Prepare a question paper. Prepare a question paper taking 25% questions from each. Ensure at least 50% questions are competency based. 30% are based on ability to recall. And 20% on applications of concepts. So I'm bringing in my Bloom's taxonomy here. So since I have not attached 4 chapters, it might ask, and let me see if it picks up from what I uploaded earlier. So I've just given this prompt, and there is, you can see here, there was mathematics in terms of, so it says excellent, well-structured paper or class 4 EVS based on the 4 chapters you shared. And it will then create my paper and I can download that. Since I did not upload it just now, it will search from the previous database, but it is capable of doing that. It is capable of doing answer key. I can download my file. It is capable of creating question papers. So I've tried all of this in past and it works very well. And I, ask it, I create one set, then I ask it to create 3 more sets similar with answer key. It does that. And it all depends on your paper, prompt what you are giving. So for example, if you see my previous prompts, so I also uploaded the blueprint of the question paper, and the blueprint says from whatever chapter, how many questions. So this is really amazing because see, these 4 chapters I uploaded. So it says perfect. You have shared 4 chapters so far. And then from 4 chapters, I asked it to create match the following. Then I asked it to create fill in the blanks competency based question. So this is very much doable and you can try this. Okay. Coming to the last section of the chapter of the book here. So after that, it talks about recap. After recapitulating, it gives you some question. First set of question is multiple choice questions, which I am sure is not that is difficult to do. So we have revised just now all of this. So this is a multiple choice question section. Then there is assertion reasoning questions from the same chapter. Then there is fill in the blanks. And after that, true, false, and short answer and long answer type question. Now there is this lab work. So it says that look at the bar graph below showing students' favorite fruit and answer the following questions based on the data. Now this is one set of question which is being given. Now I'll tell you one more easiest example. For example, you have your geography book, and or if you are an an economics teacher wants to give, or commerce teacher wants to give a question to the students where she wants the follow-up questions to be almost same but the graph to change. You don't want to give the same graph in the question paper which is given in the book. So there is a beautiful AI powered feature in Excel app on your mobile. It is feature only in mobile app. You download the Excel app and there is a camera button in the app, and you open that camera button and scan it can scan 2 things. One, it can scan tables and it can scan the graphs. So you scan that and it will ask you that do you want to convert it into soft copy? You say yes. Then your data will be converted into Excel spreadsheet. You can change the data and then it can recreate the graph for you. So that is again an AI powered feature of Google Lens. It analyzes your table in hard copy and convert those into soft copy. That's also very useful and you can try that. So this was the chapter all about. So we understood how AI can be used in mathematics, from identification of faces to weather forecast to self-driving cars. So there is everywhere mathematics, there is everywhere prediction, there is everywhere probability, there is everywhere pattern recognition. So all of this forms the base of AI. And the yesterday's example, which we did about Google Teachable Machine, where I showed you patterns in sound. You could also, have image identification model, or you could have even the there were 3 kind of models: image, text, and voice. So you could try those as well on Google Teachable Machine. They are also examples of mathematics in AI because it understand pattern and it use probability to a great extent to guess the correct answer. So I think I have covered the chapter. If you have any questions to be asked, if any point is not clear, in this, if I take you back to the book part here in the software. So what is interesting that you could share with the students when you start is your video resources are good. One introductory video is being given here. So, and another thing is your resources. So let's just quickly see this video as well.
Statistics and Probability for AI. Chandrayaan-3 stands as a testament to the incredible achievements of ISRO, successfully landing the Vikram lander and deploying the Pragyan rover on the moon. This complex mission involved not only launching a rocket but also precisely landing the lander on the moon's surface and remotely controlling the rover. While even we humans sometimes struggle to control vehicles on Earth's roads, how did scientists achieve such extraordinary precision in navigating the spacecraft, ensuring a safe landing for Vikram, and guiding Pragyan's movements on the challenging surface of the moon? Let's explore. Learning objectives. By the end of this chapter, you will be able to explain how mathematics plays a crucial role in artificial intelligence. Recognize the importance of patterns in understanding real-world phenomena. Explore role of statistics, probability, linear algebra, and calculus in AI applications. Identify examples of math in daily life and its relevance to AI.
Now, see here, this is one thing which I would want, means as a teacher, for you to, discuss with your students. For example, the just now we generated one image. So I'll just come back here. We were generating the image recently. Why I want to come back here, there is a term that is being given in the generative AI chapter, which we did yesterday. And there was something called fake, which we were discussing in the challenges. Said there is something called fake video, fake images. So while we generated the image just now, my image here, that balloon image which we just now generated. So if you show that image to the students, now this will come show me yesterday's image which we declared, because I'm not sure where I generated. Now when AI started to generate, so what happened when AI started to generate images in the beginning, the faces were like cartoon faces, and everybody could make out that these are AI generated images. But look at this image which it has generated just now. For yesterday we generated, and the one which we generated just now for balloon seller, those images look like real people. So there it is very difficult to differentiate between fake images or fake video or real images or real video. That's the biggest challenge. So when you do these kind of experiments in front of children, you can tell them that this is something which is little very scary. Okay, I before we conclude today's session, one more example since we have time. So for example, I'm asking what is we really use in school that could help you in terms of use of generative AI. For example, on a given day in a school, there can be 5 to 8 teachers absent, and doing substitution could be very tricky. And how to engage children productively, especially if you go to a class where you don't teach. Now, what we usually do, we ask teachers, when you see your substitution log in the morning, you see what is where you have to go and what is the age group of that class. And if you do not have anything to engage them and you want to complete your own pending work, still at that same time ensuring children don't waste time. So just go on the internet, find out what is a relevant and important day during that week or on that day. For example, you say that today is, let's say this week is Diwali celebration week in India. And then I'm writing uh, it goes for more than 4 or 5 days. I want to give an unseen passage to my class 6 students in 200 words on the importance and relevance of these festivals, highlighting culture, values, etc. And then I'm saying the passage should be followed by 15 MCQs and 2 open-ended questions. Then I'm writing also give a answer key for teacher. So what I usually do, I've trained my teachers like this. So be it Word Elephant Day, be it any specific day, they just pick up on the internet any significant day today or in this week. Then they generate an unseen passage using generative AI, followed by questions. So I wrote 200 words. You could even write 500 words depending on the class that you are going to. And after that, so it will have questions. And then after 15 MCQs, it will have your open-ended questions. And then you can say that give it to me as a, give this content to me. Bracket mein I'm writing other than answer key as a printable PDF or doc, whatever you want. If you want to put your school logo, say doc, then it will give as a printable PDF. And you can simply take printout and go to the class. So that is the power of AI in the hand of a teacher. So while you can do your own work in a cover class, children can do these passages, and towards the end, you can display the answer key on your projector and ask children to exchange sheets and check it. Definitely, it has some stationery expense to print the spreadsheets, but that's the power of generative AI in the hand of a teacher. So here it was asking me, do you want a Word format? So I should have said yes here only, but it is now say printable Diwali unseen passage. If I click here, it will start to download and I will get my passage ready to print. So if you see here, it's a clean passage ready to be printed, followed by questions, and it adjusted in a single page to save stationery. And even if you want to adjust it on half a sheet, you could do that. So thank you so very much, everyone, for joining. If you have more questions or queries related to the 3 chapters which I did with you, please feel free to ask those. We can have 5 minutes spent on the question answers if anyone has any questions. Yes, we can create a presentation using ChatGPT. You have to give a clear outline. I've created it multiple times. However, with ChatGPT, it gives you textual concept, content on the slide. But if you want a PowerPoint presentation with visuals, with effect, better use Gamma.ai. Gamma gives you a better tool to create PPT. It's very easy to use tool. Let me just quickly show you Gamma. It's super easy to use. You just have to create a free account. In the free version, you can create a certain number of PPTs for free, and you can remove the backdrop Gamma that it gives you in free version after downloading it and removing it from master slide. So Gamma app is best AI presentation maker. You have to give the prompt and then it will generate. You have to give little outline. For example, if I say that I'm looking for a presentation on to teach photosynthesis to class 5 and I want to cover information about the importance of sunlight, importance of green pigment, whatever you want to write, it will exactly create a PowerPoint presentation with images, etc. So if you see, there are many tutorials of Gamma also. So you click on Gamma AI Presentation Maker, it will open it for you, and then in few simple steps, you will be able to create your presentation. Let me, this is working little slow today. I don't know, my internet is okay. You sign in into Gamma and then first of all, you need to create an account. And then you can give the prompt to create a presentation. So for example, if I create new, I already have my account. So if I click on create new with the help of an AI, For example, 5 days ago, I created a presentation on the topic tie and dye based on the NCRT chapter. So I gave the chapter prompt and I wrote, or this is like, for example, create a presentation on addition of two numbers, create a presentation on seed germination. So for example, if I go to this presentation, I just gave the prompt, then AI generated the entire presentation for me. So if I say generate, so this was my prompt. So I think I exhausted my limit. I generated it. So I go back and show you already generated one. On my screen, there has to be. Okay, this was the presentation that it generated last time. And when I said done, it also, gave me the presentation. It gave me the entire thing. It says you are now out of credit because I've already tried it multiple times for free. But I'm sure if you will try, it will give you with images, because in previous demos, I've shown teachers what kind of visual it create. First, you give your prompt. After giving the prompt, it will show you slide-wise content. Once you approve the content, it will ask you to select the visual theme. You select your visual theme, then illustration style, and then click on generate. Then it will give you a very good presentation at the click of a button. So that's doable. Any other question that you want to ask? Problem here is when you use these tools without buying the plans, you have your daily limits. And since I use it too often, I exhaust by the end of the day my all free limits. So I would recommend, I have a paid account for Copilot, which I use very oftenly. So at least have one paid account. Even Magic School, I have paid account. So similarly, you can decide which tool is most useful for you and buy at least one or two paid accounts so that your work becomes very faster. Because if you have paid account and if you use it very oftenly, then what happens, machine also learns your style of working, and then you get more personalized answers. So if somebody has a chat GPT paid account, you will see your GPT's outcome and speed is very fast because it understands your way and it is trained on your data. So that makes sense to invest into AI tools also. Thank you so very much, everybody, for joining. If there are no more questions, we will close the meeting. And once again, thank you for joining.
Thank you, ma'am.